Good evening and welcome back. In my previous video, I showed you how to expand sine A plus B, sine A cos B plus cos A sine B. I hope you understood. So this is the second expansion, which is cos A plus B. I use the same figure. And if you could see through the expansion of sine A plus B once again, you might become familiar with the figure and how I drew this diagram. So I'm using the same diagram here to expand cos A plus B, and we use the right angle triangle OPQ here. It is basically the same process. From the triangle OPQ, cos A plus B is OQ divided by OP, adjacent over hypotenuse. I'm talking about this angle here, which is A plus B. So cos A plus B from the triangle, right triangle OPQ is OQ divided by OP. This OQ can be written as OS minus QS. So OS minus QS divided by OP. Now I split the numerators and I write it as OS over OP minus QS over OP. OS over OP minus, if you see QS, the side QS is not part of any right angle triangle. So I just replace this QS to be TR because TR is part of the small right triangle, PTR. All right. So now we have OS divided by OP minus TR divided by OP. If you see this OS is part of the triangle OSR and OP is part of another right angle triangle OPR. So OS and OP belong to two different triangles. So hence we try to include a common side which works for both. And it's obvious here if you look at it, OR could be a common side with OSR and ORP. All right, so we just include OR. And I mentioned in the previous proof that if you just cross it out, cross this numerator and this denominator OR, you will have the same ratio as before, OS over OP. The same thing here, if you see TR is part of the small right angle triangle and OP is part of a larger right angle triangle OPR. Therefore, we try to include a side which is common to both triangles. In this case, it looks PR, which is obvious because PR becomes part of PTR, the small right angle triangle, and PR becomes part of the bigger right angle triangle OPR, right? So PR could be included in this case. Now let us see what OS divided by OR, the ratio means. OS divided by OR, which is basically adjacent over hypotenuse when the given angle is A. So I could just write OS over OR as cos A. Hope you could follow me. The next ratio is OR over OP. OR divided by OP is basically adjacent over hypotenuse with the triangle OPR as given angle B. So for the given angle B, OR divided by OP will give us cos B. Will give us cos B. It's here. Minus TR divided by PR. Let us see where TR is. TR is part of the small right angle triangle and PR is here, the same small right angle triangle. So TR and PR is basically the opposite divided by the hypotenuse for the given angle A. So I could write this as sine A, which is TR divided by PR. The final ratio that we have is PR divided by OP. PR is here and OP is here. It's part of OPR, right? So if you look at the given angle B, PR is the opposite side and OP is the hypotenuse. So therefore, PR divided by OP could be written as sine B. So here we have the expansion like cos A plus B is equal to cos A cos B minus sine A sine B. And double angle formula with cos, which is cos 2 theta, could be written as cos theta plus theta. And following this expansion, cos A plus B is cos A cos B minus sine A sine B. We would just expand cos theta plus theta. In place of A, you have theta. In place of B, you have theta. So therefore, you have cos theta times cos theta minus sine theta times sine theta. Cos theta times cos theta is cos squared theta. Sine theta times sine theta is sine squared theta. Therefore, you have cos squared theta minus sine squared theta. So cos 2 theta could be written as cos squared theta minus sine squared theta. When we discussed sine 2 theta just has one form, which is 2 sine theta cos theta. But in cos, when it comes to cos 2 theta, we have three different forms. One is this, cos squared theta minus sine squared theta. Now, if I rewrite cos squared theta as 1 minus sine squared theta in the same expansion, you already have this minus sine squared theta, which is this. I'm just saying replace this cos squared theta as 1 minus sine squared theta, and you already have 1 minus sine squared theta. So therefore 1 minus sine squared theta minus sine squared theta is 1 minus 2 sine squared theta. And one more case, if you replace this sine squared theta as 1 minus cos squared theta, and you just leave this cos squared theta as it is here, this cos squared theta stays as it is, and you will replace this sine squared theta as 1 minus cos squared theta. And you open the parenthesis here, cos squared theta minus 1, negative of negative becomes positive. So therefore you have positive cos squared theta. So cos squared theta plus cos squared theta is 2 cos squared theta minus 1. So when it comes to cos 2 theta, you have three different forms. One is cos squared theta minus sine squared theta. The next one is 1 minus 2 sine squared theta or 2 cos squared theta minus 1. So this is the proof of the double angle formula, which follows the expansion of cos A plus B, which is equal to cos A cos B minus sine A sine B. I hope you understood both sine A plus B and cos A plus B. I mean the expansions of sine A plus B and cos A plus B. And thank you for watching. If you are watching this video, please like, share, and subscribe, and do comment so that we could discuss further. And I will see you all in my next video. Thank you once again.